A warm wishes to everyone. We are Gayatri from Anna University, Chennai. The topic of our project is System Dynamic Simulation Modeling for Transportation and Energy Interaction. So, why should we relate transport and energy sector? It's because due to more utilization of energy in vehicles, carbon dioxide emission increases, which in turn degrades the environment and reduces the quality of life. The transport sector in India itself utilizes 19% of global energy use and is projected to reach 50% by 2030. This current study provides optimal solution focusing on a large comprehensive thought process and on policy issues on the need to move people rather than vehicles. Why this study is needed for the hour? The primary energy demand of transport sector at present is 11% and is likely to double to 20% by 2030. Indian share is likely to triple from 2% in 2005 to 6% in 2030. Therefore, a proper planning is required to reduce energy demand and reduction in emissions. The main objective is to study the existing and future transport demand and supply in Chennai city and to build a system dynamic simulation model using Stella software. From the model results, appropriate mitigation measures are suggested for achieving a sustainable judicial transportation mix. Our study area is Chennai city. Chennai is the fourth metropolitan city in India with a population of 4.79 million. The rapid increase in population leads to traffic congestion and more utilization of energy. Therefore, the model is developed for population, transport and energy sector. The data for various sectors were collected from the Chennai Metropolitan Development Authority and Census India. Next comes the model development process for the three sectors considered. First, population model was built by taking birth rate and in-migration as inflow and death rate and out-migration as outflow. Then, individual models were developed for public and personalized vehicles. The base year is taken as 2011 and the projected year is taken as 2026. These are the two models developed for two-wheelers and IPT vehicles separately. This is the model developed for public sector. In this model, total number of buses is taken. Growth rate for buses is increased for every year up to the projected year in order to increase the public sector vehicles. Likewise, the growth rate for personalized vehicles is decreased for every year to save energy utilization. The bus increase is nothing but the product of total number of buses and the growth rate for buses every year, and this is given as an inflow. The fuel consumption for buses is found from the product of fuel efficiency per bus, the average distance travelled per day per bus and the total number of buses. Bus trips are found out by dividing the total number of buses by the trip rate per bus. These are the two models built for determining the share of public and personalized trips and the total fuel consumption for the transport sector. The results. Three scenarios were analyzed. First one is U minimum scenario, which means what happens if the existing trend of growth rate of vehicles is allowed to continue till the year 2026. A model split of 45:59 is achieved for public and private sectors respectively. Due to this scenario, overall GDP loss continues to be 15%. The quality of life and value system contributes 20% to the national prosperity index. Next comes the partial scenario, which means augmentation of public transport by increasing its growth rate in a phase-wise manner and restricting private vehicles to a minimum. Modal split of 64:36 is achieved for public and private sector respectively in this scenario by incorporating CNG by 15%. The CNG is used here because it is a natural gas and so the emission will be reduced, leading to the sustainable environment. The hypothesis considered in this scenario is that one bus can replace 19 cars and 38 two-wheelers. Thus, the fuel consumption is reduced to 40% compared to the scenario 1. The overall GDP loss is to about 7% and the value system and the quality of life contributes to 50% to NPV. The last one is nothing but the desirable scenario, which means augmentation of public transport by increasing its growth rate in a phase-wise manner and restricting personalized vehicles to a maximum. The modal split of 70:30 is achieved for public and private sectors respectively. The result shows a reduction of 34% in the demand for diesel cars, 33% in the reduction of petrol cars, and 12% in two-wheelers by incorporating CNG by 50% and introducing fuel cell vehicles by 2 lakhs by the year 2030.
Some of the recommendations that are suggested from the study is the need to restrict the growth of personalized vehicles and augment the public transport by increasing the MTC fleet size, BRT, introduction of metro and monorail in the city. Though desirable scenario is hard to achieve, to the minimum, the government should strive to achieve the partial scenario. Use of alternative fuels like CNG and LPG should be encouraged in order to reduce the demand for petrol and diesel and also reduce the air pollution from the vehicles. Euro 6 emission norms should be made mandatory sooner. This reduces emission load from vehicles. Lastly, losses due to fuel import, fuel price hike, air pollution and road safety could be decreased to a substantial 2% from the existing 15% to achieve a GDP growth rate of 12% in 2026. Thank you.